For the past few years, artificial intelligence has functioned like a highly advanced encyclopedia. You input a prompt, and it generates text. But computing is abandoning systems that simply answer questions in favor of systems that now autonomously execute actions. This previous era relied entirely on the monolithic chatbot. Users interacted with a single, sandboxed foundation model that attempted to process every possible type of request in one isolated environment. The limitation of this approach is structural. When a single model is forced to navigate a complex multi-step workflow, like retrieving internal data, writing software code, and deploying systems, it rapidly degrades in accuracy and begins to hallucinate. Today's enterprise operations require true headless execution. Instead of a human manually typing prompts into a chat interface all day, multi-stage workflows must run entirely in the background. To solve the constraints of the single-turn chatbot, developers are deploying agentic architectures. This is an interconnected ecosystem. It replaces the single generalized model with a network of specialized autonomous AI agents that collaborate to achieve a massive objective. Building this ecosystem requires three distinct layers: structural frameworks to govern how agents think, interoperability protocols to connect them to external data, and strict identity governance to secure their actions. Achieving autonomous execution does not require building a smarter, larger foundation model. It requires architecting a better network. A traditional corporation does not hire one employee to serve simultaneously as the lead engineer, financial officer, and data analyst. It hires specialists. Modern AI deployment follows the exact same logic through domain expert agents. Developers build specific entities for distinct functions. A RAG agent is deployed strictly to synthesize internal company PDFs. A code agent is deployed exclusively to write and debug software. A web search agent is built solely to extract live internet data. Narrowing an agent's operational scope eliminates the processing burden of generalized tasks. This focus yields exponential increases in speed and reliability within that specific domain. In this diagram, we see the central management layer required to control these independent experts, the orchestrator. The orchestrator does not execute tasks. It does not solve the problem directly. It acts purely as a manager, coordinating the workflow. The process begins with task decomposition. The orchestrator receives a massive goal and breaks it down into bite-sized, actionable steps. Step 2 is contextual routing. The orchestrator analyzes the specific expertise of the available agents in its network and routes the corresponding task to the correct expert. The final step is synthesis. The orchestrator gathers the independent outputs from the specialized workers and compiles them into a cohesive final execution. If an enterprise user inputs the prompt, "Analyze our competitors' Q3 earnings and write a script to scrape their new pricing page," the system does not attempt to generate a single block of text. The orchestrator strips the prompt apart. It delegates the financial analysis request to the data agent, routes the scraping request to the code agent, and waits for their specific outputs. While the orchestrator pattern solves complex task delegation, an unstructured network of specialized agents communicating without constraints will quickly devolve into chaos. To prevent autonomous workers from hallucinating or entering endless execution loops, developers rely on the agentic stack. These frameworks establish the structural rules of the network. Looking at this diagram of Microsoft's AutoGen framework, we see a conversing agents topology. This structure allows multiple specialized agents to iteratively debate. They check each other's work and issue corrections in a continuous loop to solve complex coding environments. Not every enterprise workflow requires open-ended debate. Lightweight frameworks like OpenAI's Swarm or Anthropic's Claude teams take a highly structured approach. These frameworks optimize for reliability. They eliminate debate entirely, enforcing strict handoffs and routines through rigid execution paths. For organizations requiring extensive custom logic, modular frameworks like LangGraph and CrewAI provide precise architectural control. Developers use these modular tools to explicitly define memory sharing parameters and establish strict hierarchical relationships, ensuring a worker agent can never override a manager agent's directive. The selection of a framework establishes the blueprint for the entire system. It dictates exactly how the enterprise's AI agents think, communicate, and collaborate. A perfectly orchestrated internal network is entirely useless if it cannot securely read from or write to external production systems. This chart illustrates the N times M integration problem. Historically, every time a new AI model was deployed, developers were forced to build custom integration pipelines for every individual piece of external enterprise software. To eliminate this unmanageable chaos, the industry adopted the Model Context Protocol, or MCP. MCP functions as a universal USB-C port for artificial intelligence. It provides a single, standardized connection point between the intelligence layer and the data layer. The protocol operates independently of any specific agentic framework, serving as a universal bridge for both cloud-hosted models and offline, locally hosted systems. Because of this standard, an agent built on Amazon Web Services infrastructure can natively and seamlessly execute actions within third-party software like Salesforce or GitHub. Standardizing the connection layer is the only mechanism capable of scaling multi-agent networks securely across the digital landscape. Empowering autonomous systems to move data and execute actions introduces a severe security vulnerability known as the agent identity crisis. Current audits reveal that only 23% of enterprises possess the tools to inventory non-human entities. When an orchestrator spins up temporary subagents and grants them ad-them-adla access to secure databases, the resulting identity sprawl is entirely untracked. Operating in this governance void invites catastrophic risk. Over-permissioned agents can hallucinate the authority to delete files, and without strict identity bindings, it is impossible to determine legal accountability for rogue actions. To secure the infrastructure, governing bodies intervened. The defining standard established for autonomous oversight is the 2026 NIST Trust Framework. The framework forces a shift in enterprise security architecture. It abandons the trust but verify model in favor of zero trust for non-human entities. Notice this agent passport. This cryptographic credential is required when accessing external tools. It logs the agent's origin and maps to a human principal, the employee legally responsible. It enforces operational constraints, explicitly preventing unauthorized writing, while the time-to-live metric forces self-termination. The complete architecture requires all three elements. The framework dictates the logic, the protocol dictates the connections, and the passport dictates the security. Mastering these three structural pillars separates an isolated software novelty from a secure, autonomous enterprise workforce.